Assalamualaikum and good day to all, especially to my panelists, Dr. Muhammad Ali Ahmad and Sir Khairul Imran Sainan. Let me introduce myself. My name is Muhammad Azamuddin Bin Sulaiman. My student ID is 2019689746 and I am under Dr. Muhammad FAIZAL as my supervisor. My old topic title was CFD Simulation of Pollutant Dispersion in Cross-Ventilated Building, and my updated title for my FYP is CFD Simulation of Pollutant Dispersion in Cross-Ventilated Building with Symmetrical Opening Position. In this presentation, I will be talking about project summary, introduction, problem statement, objective, scope and limitation, literature review, methodology, expected results, and references on my research study. Starting with project summary, building experts and engineers needs to know about the distribution of air pollutants when designing a building. To doing so, we use CFD simulation to create the dispersion of airflow around buildings. In this project, it will be focused on dispersion around a single structure because this is the most basic scenario for dispersion in a city. Furthermore, the objective of this project is to investigate the flow pattern and evaluate the pollutant dispersion in cross-building with symmetrical opening position. In doing so, using OpenForm software, a 3D building with symmetrical opening position will be created as a model of the pollutant dispersion. Proceed with introduction. Outdoor air pollution is one of the key issues nowadays. It can cause chronic health problems to people like us. The pollutants released into the atmosphere by variable of sources. The dispersion in an urban environment is called as micro-scale dispersion. These micro-scale dispersion are caused by building geometry, wind speed, wind direction, temperature, sun radiation, and many more. For indoor air pollution, it is created by the same building re-inhaling contaminated exhaust air or by intake of exhaust from other sources such as surrounding building, traffic, car parking lots, and loading docks, emergency generators, and cooling towers. Talking about problem statement. Before this, there were some field tests has been conducted. The data obtained is valuable and accurate. However, it is impossible to predict the flow pollutant dispersion if a new facility or building has not yet been constructed. So we need a CFD simulation to create the pollutant situation before considering creating a new building. In this research, some of the problems that we need to consider are how the flow pattern behaves in cross-ventilated building with symmetrical opening position, and how does opening affects the pollutant dispersion behavior. So as for my main objective or the goal of this research, I want to investigate the flow pattern within cross-ventilated building with symmetrical opening position and evaluate the pollutant dispersion within the cross-ventilated building. There are scope and limitations in the research. The main scope is focusing only on pollutant dispersion through wind at one direction. Other type of pollution will not be included. The 3D building will be symmetrical opening position as the model. The simulation will be only focused on an isolated ventilated building. The limitation of the research is the source of pollutants are too many and not consistent. Hence, a building will be considered as isolated building. Okay, so in this part, I will be talking about the literature review. Indoor air pollution from outside air pollutants can be caused by the ingestion of contaminated exhaust air by the same building, or by the intake of exhaust from other sources, such as nearby buildings, street traffic, vehicle parking lots, loading docks, emergency generators, and cooling towers. That is according to Smeaton 1991 and Maroney 2008. Wind catchers have been highlighted as a high potential technology for facilitating natural ventilation in buildings in previous studies. Hargers and Saratian, Jomezat, and Razin 2016 present an outline of the development of wind catchers. Even though wind catchers have long been recognized for their utility, the concept is currently generating renewed interest as an environmentally responsible alternative for addressing the demands of modern building design. Several studies use numerical or experimental methods to investigate pollutant dispersion in cross-ventilated buildings with a focus on greenhouse or livestock buildings, such as the studies of Bazanas and Norton 2013, who used two-dimensional and three-dimensional as well as steady and unsteady Reynolds average numerical simulations (RANS) runs. Van Hoof and Blocken 2008 observed and computed the CO2 dispersion via natural cross-ventilation in a large stadium unsteady runs. In this section, I will be talking about methodology. Picture on the left is a building with symmetrical opening position at the upper side of the building, and the right picture shows the domain of the building. The simulation that will be created is the wind pollutant comes from Z direction. When the wind hit the building area, we will be able to see the dispersion flow of the wind going inside the building and the building surrounding. We will also be able to observe the level of pressure dispersion when the wind goes inside and exits through windows, which both of the windows located at upper side of the building. So this is the expected result of this study, where the main objective of the case study can be considered a success, where the simulation of flow pattern dispersion in cross-ventilated building with symmetrical opening position has been made. The figure shows that how the outdoor pollutants flow inside then exit through the windows, which is the same level. We can observe that the red area is a high pressure of wind dispersion that disperses on top of the building. The wind that flows inside and exits is yellow, which indicates middle level of pressure. So this is all the references that I used to create my proposal for my FYP1, and can be found also on my proposal report. So that's all my presentation for my FYP proposal. Thank you for listening.